Okay, so this video is all about volumes of 3D shapes. So the first set of questions are all non-calculated questions. Remember, you can see all these on the PDF on MathsUpgrade.co.uk. So question 1, the total surface area of a cube is 294 centimeters squared. We have to work out the volume of the cube. Okay, the way I'm going to do that is I'm going to find the area of one face, then we should find the length of one edge, and then knowing that length of that edge we can then find the volume of the cube using length times width times height. So here's the steps I'm going to take here. Okay, I can find the area of one face since I know the total surface area of the cube, and the total surface area is all 6 faces areas combined. Since each face is equal, I can just do 294 divided by 6. Using short division, that gives me 49. Now, since 49 is the area of one face of that cube and each face is a square, to find the edge of one square, I can just square root 49, and that gives me 7 centimeters. To find the volume of the cube, it's quite simply a matter of just doing 7 times 7 times 7, since the length, width and height are all 7, and that gives me 343 centimeters cubed. And that question there is 4 marks. Question 2 gives me a diagram which shows a fish tank in the shape of a cuboid. The dimensions of the tank are 50 centimeters by 32 by 20, and those dimensions are marked on the diagram as well. The tank is 3/4 full of water and sand. The ratio, or the volume of water to the volume of sand, is 5 to 1. Work out the number of litres of water in the tank. You must show all your working. So in this question, it's almost given the order in which you need to do things. So the first thing you need to do is you need to find the whole volume of the tank. Once you've found the entire volume of the tank, you can then find the volume of the water and sand combined. Then given this ratio, we can then just find the volume of the water, and then we can convert that into litres. So here's the steps I'm going to take. So let's first of all use this formula here to find the volume of that entire cuboid. So 50 times 32 times 20 is the same as 1000 times 32, which is 32,000, and that's obviously done without a calculator. Now, since the water plus sand is 3/4 of the entire tank, then I need to find 3/4 of this volume to give me the volume of the water and sand combined. So 3/4 of 32,000. Well, I can find 1/4 by just dividing by 4, which is 8,000, and then multiply by 3, and that's 24,000. So the next part is I'm going to find the volume of the water. And the volume of the water, well, in this ratio here, you're told that the volume of water to the volume of sand is 5 to 1. So in other words, there's 6 parts altogether, and 5 of them are water. So 5/6 of this volume here is water. So we're going to find 5/6 of 24,000. So in a similar way to this, I'm going to find 1/6 of 24,000. So 24,000 divided by 6, which is 4,000, and 4,000 multiplied by 5, which is 20,000. That's in centimeters cubed, since I've used centimeters cubed all the way through this question. Now, since I need to work that out into litres, well, I know that 1,000 centimeters cubed is 1 litre. You need to recall this information because you're not given that in the exam. So if I divide this by 1,000, that will convert it into litres, and that whole question there is 5 marks. Question 3. This diagram gives me a sand pit. The sand pit is in the shape of a cuboid. And I'm given the dimensions of that diagram are there as well in centimetres. Sally wants to fill the sand pit with sand. A bag of sand costs £2.50, and there's 8 litres of sand within each bag. Sally says the sand will cost less than £70, and we're told that she's definitely wrong, but we have to show it mathematically. So in this question, I'm going to do 4 steps. The first thing I'm going to do is I'm going to find the volume of this sand pit. I can do that using the formula for the volume of a cuboid. After that, I'm going to convert that into litres, since 1,000 centimeters cubed is a litre. Then I'm going to divide the number of litres in the sand pit by the number of litres in one bag, and then I'm going to multiply that by the cost of each bag. So here's the steps I'm going to take. So let's first of all use this formula here to find the volume of the sand pit. 100 times 40 times 60, well, I can do 40 times 60 first, which is 2,400, and then 2,400 times 100 would give me 240,000. This is all without a calculator, remember. So now I need to convert this into litres. So you need to recall this information. 1,000 centimeters cubed is equivalent to 1 litre. So if I'm going to turn this into litres, I need to divide this by 1,000, and that gives me 240 litres. So 240 litres. Now I need to divide the number of litres, which is 240, by the number of litres in one bag. When I do that, that tells me how many bags I'll require. So 240 divided by the 8 litres in each bag means I need exactly 30 bags. Exactly 30 bags. If I needed slightly more than 30, let's say I needed 30.3 bags, I'd have to round that up to 31. But this is exactly 30 bags. So now I need to work out the cost of buying these bags. If each bag costs £2.50, then I just simply multiply by £2.50, and that gives me £75. So it'll cost Sally £75, so therefore she is wrong. So the entire question there is 5 marks. Question 4. So again, this question involves a tank in the shape of a cuboid. It's already got some water in it, and I'm given the dimensions of the tank originally, and I'm told that I've also got a barrel, and there's 18,000 centimeters cubes of water in the barrel. We're going to empty all the water from the barrel into the tank to join the 1/3 full of water already, and then we need to work out the depth of water in the tank. This question's 4 marks, and then there's a part B later on. So here's the steps I'm going to take. I'm first of all going to find the volume of this tank, the entire volume. Then I'm going to work out how much water is in there by knowing that it's 1/3 full. After that, I'm going to add the water of the barrel into the tank to find the total volume of water now in the tank. I'm going to find the cross section of the base of the cuboid, which is a rectangle, the cross section there. And then I'm going to divide the volume by the cross section to find the depth of water. So the first step, let's find the total possible capacity of the tank. The total possible capacity is length times width times height. That's 100 times 50 times 60, which without a calculator I can just do 50 times 60, which gives me 3,000, times 100 is 300,000. So 300,000 centimeters cubed is the capacity of this tank. Now since it's only 1/3 full of water, I need to find 1/3 of 300,000. That gives me 100,000. The next thing I'm going to do is I'm going to find the volume of this water when I've added it into the tank and see how much water I've got in the tank already. So since this has got 18,000 centimeters cubed, when I add it to 100,000, I'll get 118,000 centimeters cubed. What I'm going to do now, I'm just going to remember this figure here. I'm going to park that for a moment while I find the cross section of the base of the cuboid. I need to find the cross section of the base of the cuboid because I need to see the depth of water in the tank at the final point. So the cross section of the base, since the base is just a rectangle, I can imagine the rectangle, if I'm looking down on this tank, it will be 100 long by 50 wide. So 100 times 50 is 5,000. So since the cross section is 5,000, if I now divide the volume of water in the tank by 5,000, then I'll get the depth of water, and that is 23.6. Just as a note, remember I've used centimeters cubed all the way through this question. The volume was in centimeters cubed, so was the barrel in the question here. When I found the cross section of the base of the cuboid, this is centimeters squared, and so when I divide them through, my answer is still in centimeters. The answer is 23.6 centimeters for 4 marks, and we can see that's a sensible figure as well. So that entire question was 4 marks. Now for part B. Part B. Tina finds out that the barrel contains less than 18,000 centimeters cubed of water. So she says that the barrel's got slightly less water than that. Okay, what effect will that have on the answer on part A? Well, since the barrel's got less water, the depth will now be less, since there's less water to put into the tank. And that's quite simply what I've written here. So for that last mark, the total question now is worth 5 marks. Question 5. The diagram shows a swimming pool. I'm given the dimensions of the swimming pool on the diagram. Okay, you can see it's in the shape of a prism. So this front face here, okay, is the same cross section going all the way through the shape, so it's a prism, and that's important. It's going to be filled with water at a rate of 5 litres per second. Jeremy's got 10 hours to fill the swimming pool, and we're reminded that a meters cubed is 1,000 litres. Will you fill the swimming pool completely in 10 hours and show all your working? This question is worth 5 marks. Okay, and the important thing I need to know here is the formula which I've written at the top here. The volume of a prism is equal to the cross-sectional area times by the length. So if I can find this cross-sectional area here, and then I can multiply it by the length which I'm given here, I can then find the volume of the swimming pool. Since I know how to convert from meters cubed into litres, I can convert into litres. I can then divide that volume in litres by the fill rate, which is here, and that tells me how many seconds it will take to fill the pool. I can then compare that with 10 hours, and I can see whether Jeremy can fill it or not within 10 hours. So the first thing, like I said, we're going to find this surface, we're going to find this cross section. The cross section here is a compound shape. It's a rectangle here, and I'll split it also into a triangle here. So let's find the area of this triangle. Well, the triangle's area is just given by base times height and then divided by 2. The base and height need to be perpendicular to one another, and they are, since that's a right angle. So this must also be a right angle since these two sides are parallel. So 5 times 2 divided by 2 is 5. And the area of the rectangle is quite simply the length times the width. The width is given here as 15 and the length is 1. So 1 times 15 is 15. If I add those two values together, I'll get a total area of cross section as being 20 meters squared. Now to find the volume. Well, the volume, like I said, is given by this formula here. You need to recall this formula as well for this topic. So the volume of a prism is the cross-sectional area times the length. I found the cross-sectional area here, and the length is just the distance going backwards in this case. So that is 10. So 20 times 10 is just 200 meters cubed. The next thing I'm going to do is I'm going to convert this into litres. The reason for that is because I'm told the fill rate here is 5 litres per second. So if I need to use this later on, I'm going to turn this into litres as well. So 200 meters cubed, and each meter cubed is 1,000 litres. So times that by 1,000 and I get 200,000 litres. The next part, like I said, I'm going to divide this volume here in litres by the fill rate. And the fill rate is 5 litres per second. So 200,000 divided by 5 litres per second gives me 40,000 seconds. 40,000 seconds. Now, 40,000 seconds, I need to convert that into hours since I need to check if I can fill it in 10 hours. So 40,000 seconds, well, let me convert 10 hours into seconds since this entire question is a non-calculated question. So it's easier for me to convert the 10 hours into seconds and then compare these two values. So 10 hours in seconds, well, 10 hours is 10 times 60 minutes and then times 60 seconds. So that is 10 times 3,600, which is 36,000 seconds. So he's got 36,000 seconds available to fill that swimming pool, and it will take him 40,000 seconds. So he's 4,000 seconds short. So in other words, it won't fill in 10 hours. You don't need to say how much more time he needs, since it just says whether you can fill it or not, and that's the only reasoning you need. If you get all that question, you get all the working out as well, then that question is worth 5 marks. So in question 6, I'm given a cuboid. I'm just given the dimensions as algebraic terms. Okay, I'm told that all the measurements are in centimeters. I'm told that x is a whole number. I'm told that the total volume of the cuboid is less than 900 centimeters cubed. I need to show that x is less than or equal to 5. So in essence here, I need to form and solve an inequality. It will actually be a quadratic inequality, but you don't actually need knowledge of quadratics to solve this question. So the first thing I'm going to do is I'm going to write the volume of this cuboid and compare it with this information here. Since the volume is given by the length times width times height, I'm going to write those algebraic terms here. The length is 3x, the width 2x, and the height x. Multiplying them all together and then putting that as less than 900, since that's what that statement says there. If I collect these like terms by multiplying, I get 3x times 2x, which is 6x squared, times x again is 6x cubed. So that is 6x cubed, which is less than 900. Now to solve this, first of all I'm going to divide both sides by 6 to balance the inequality out. That'll give me x cubed, which is less than 150. Now I need to find the inverse of cubing, which is cube rooting. So if I cube root x cubed, I get x. If I cube root 150, I get 5 point something. Right, and now since x is an integer, okay, the next lowest integer after 5 point something is 5. So x is definitely going to be less than or equal to 5. The whole question there is worth 3 marks. Just an additional note, remember x can also be equal to 5 since the solution for this was actually greater than 5. Question 7 is worth 4 marks. I'm given a container in the shape of a cuboid and I'm told that it's 2/3 full of water. I'm told that a cup can hold 275 millilitres of water. I need to work out the greatest number of cups that can be completely filled with the water from that container. I'm given the dimensions of the container on the diagram. So the first thing I'm going to do is I'm going to find the total possible volume of the cuboid. Then I'm going to find the amount of water when it's 2/3 full. I'm going to divide that by the volume of 1 cup. So let's do that now. So here's the steps I'm going to take. I've underlined the key information. I've also just made a note that 1 milliliter is actually 1 centimeter cubed. So you need to remember this as well. And you need to recall this for the exam. So first of all, let's find the volume, and I've written it down here within the cuboid itself. Volume is given by the length times width times height, 30 times 6 times 19. Since I'm allowed a calculator in these questions now, that's fairly straightforward. So this would be in centimeters cubed, in other words in milliliters. Second thing I'm going to do, I'm going to find 2/3 of this value, since the container is only 2/3 full of water. So 2/3 of this on a calculator will give me 2,280 centimeters cubed. Now to find the number of cups, this is the amount of water I need, and this is how much each cup can hold. So if I divide those two values through, since they're both in milliliters or centimeters cubed, I'll get 8.29. Now, since it asks what's the greatest number of cups that become completely filled from the water, that means it's going to be 8, since I need to round it down to the nearest integer. The entire question there is worth 4 marks. Question 8. So I'm given a diagram which has got a cube and a cuboid in there. I'm not given the dimensions of the cube, but I'm told the length and width and height of the cuboid in the diagram. But I am told the total surface area of the cube is equal to that of the cuboid. Janet says the volume of the cube is equal to the volume of the cuboid. Is she correct? And show how you get your answer. So in this question, what I'm going to do, I'm going to find first of all the surface area of the cuboid. If you're not sure how to do that, look back at my video on my channel on surface area. I'm then going to find an edge length of the cube. I'm going to find the volume of the cube and the volume of the cuboid, and then I'm going to answer the question stated on whether Janet is correct or not. So here's the steps I'm going to take. Because I'm finding the surface area and it's not within this topic, I'm just labelling each visible face here just to show you what I'm doing. So the surface area is essentially the area of all the faces of this cuboid. So if I find the surface area of the visible faces first, these 3 faces which I can actually see, and then if I double my surface area to get the total surface area, then that's what I'm doing. So the first thing I'm going to do, I'm going to find the area of the front. The front here is just a rectangle, and the area of that is just length times width, 6 times 8. Similarly, the top here is 18 times 8, and the right hand side is 18 times 6. I work those out with a calculator, and now when I add those up, I then get 300. Doubling that to find the total surface area of all 6 faces is 600 centimeters squared. Now I'm going to find the edge length of the cube. I can find the edge length of the cube since I know the area of one face of this cube is going to be the total surface area of the cube, which is the same as that of the cuboid, divided by 6, since it's got 6 equal faces. So 600 divided by 6 gives me the area of one face, which is 100. Now if the area of one face is 100 and each face is a square, since this is a cube, I can square root 100 and that gives me the length of each edge. So the length of each edge must be 10. Now that I know the length of each edge of that cube, I can find the volume of it, since the volume is given by length times width times height. So that is 1000 centimeters cubed. Similarly, I'm going to find the volume of this cuboid, which I could have done right at the start, and that gives me 6 times 8 times 18, which is 864 centimeters cubed. So now we can see whether Janet is correct or not. She stated that the volume of both of them are equal. Well, here's the volume of the cube, here's the volume of the cuboid, and we can see that they're both different. So she's incorrect, the volumes are different as shown above. So that whole question there is worth 5 marks. Again, if you're not sure how to find surface area, be sure to look at my video clip on my channel. Question 9. A lot of the questions we've seen so far in this booklet have involved cubes and cuboids. This question involves a triangular prism. At first glance it looks fairly straightforward to find the volume of this as long as I know the formula, but actually I need to use Pythagoras first of all. If you're not sure on how to use Pythagoras, be sure to look at my video clip on my channel beforehand. So what I'm going to do here, I'm going to use Pythagoras to find the length of this edge here. Once I've found the length of this edge, I can find the area of this face. This is important since this is the cross section of the entire prism. This cross section is constant through the entire prism. Once I've got that cross sectional area, I can then multiply by that length 18, and that'll give me the volume. So let's use Pythagoras first of all. From Pythagoras, I know that the square on this shorter side is the difference of the squares on the other two sides. So if I can do 8.4 squared, 7.2 squared, subtract and square root, that gives me 4.327 with a calculator. Now I can find the cross-sectional area, the area of this triangle. The area of a triangle just given by base times height divided by 2. So if I multiply those two values together and then divide by 2, I'll get 15.58. Now to find the volume, I just apply this formula here, which we've been using throughout this booklet. So the volume is just the cross-sectional area times the length. Here's the cross-sectional area which I found. There's the length going back through the shape. Multiply them together and then round it to 3 significant figures. Let's just check the units are in centimeters cubed, and I've used centimeters throughout this question, so that is fine as well. The entire question is worth 5 marks, and that's how you do it. Question 10. I'm given an oil tank in the shape of a prism. The cross section of the prism is a trapezium. So it's got the trapezium as a cross section, it's going all the way through the shape. It's constant. The tank is empty. Oil is going to flow into the tank, and after 1 minute we're told that there's 300 litres of oil in the tank. Assuming that the oil continues to flow into the tank at that rate, we need to first of all work out how many more minutes it will take for the tank to be 85% full of oil. For this question here, which is worth 5 marks, there's 6 steps we're going to take. The important thing here, for the very last step, is to see that this word more is in bold. So we're going to underline that as well as the key information here. So underline the key information here. Here's the steps I'm going to take. First of all, I'm going to find the cross-sectional area. In other words, the area of this trapezium. This trapezium goes all the way through the shape. So once I've found this cross-sectional area, I can then find the volume of this entire tank. Once I've found the total volume, I can then find 85% of it, since that's what I need to see when it's full. Then I can convert that into litres. I can then divide that by the flow rate, which is quoted in litres. And then I can remember to subtract that 1 minute, since 1 minute has already flown into that tank. So let's do that now. So the first thing we're going to do, we're going to find the area of this trapezium, which I've outlined here. The area of a trapezium is given by the sum of the parallel sides divided by 2 times by the perpendicular distance between them. In essence, what we're doing here is we find the mean of the 2 parallel sides and multiplying by the height. So the mean of these 2 sides is 2.2, and times that by 2.4, I get 5.28, and that again is in meters squared, since that's an area. Now I can find the total volume of this tank. Since the total volume is given by the area of the cross section, which I found here, multiplied by the length, and the length I can see in the diagram is 2.5. So multiply those together, I'll get 13.2. The next part of this question, I need to find 85% of that volume. I found the complete volume here, but we only need to see when it's 85% full. So to find 85%, I can just do 0.85 times 13.2, which is 11.22 meters cubed. Now that's in meters cubed. I'm told the flow rate here in liters per minute. So I'm going to convert this volume into liters as well. I'm told that 1 meter cubed is 1,000 liters, which you may not necessarily be told in the exam, so you make sure you remember this. So times that by 1,000 and I get 11,220 liters. Since the flow rate is 300 liters per minute, I can divide that by 300 and that gives me 37.4 minutes. Since 1 minute has already passed, the number of more minutes it will take is 37.4 subtract 1, which is 36.4 minutes. That whole question there is worth 5 marks, and there's 6 steps there for that question. So make sure you follow all through. If you had any problems with that, remember you can pause this video at any time, or you can rewind it as well. Part B, I'm told that the assumption of the rate of flow of oil could be wrong. So we need to explain how it might affect our answer to part A. We're not told whether the rate of flow is too great or too low. So we have to answer the question assuming both. So if the flow rate is slower, then it'll obviously take longer to fill. If the flow rate is greater, it will take less time. And that's all you need to write with your statements to get that 1 mark. The entire question there is worth 6 marks. Question 11. I'm given a solid metal cuboid. It's a solid. The areas of the 3 of the faces are marked on the diagram. So these are the areas here, not the lengths. But I am told the lengths are in centimeters and that they're whole numbers, so they're integers. The metal cuboid is melted down and made into smaller cubes. Each of the cubes has got a side of length 2.5 centimeters. And I can work out the greatest number of the cubes that can be made. The entire question there is 5 marks. I have answered this question as part of the surface areas booklet, and the video for that is also on this channel. But in essence, what I'm going to do here is I'm going to follow these steps. I'm going to find the length, width and height of this cuboid. I'm going to find then the volume of the cuboid. I'm going to find the volume of one of these small cubes, and I can divide those through 2 so that I can then find the number of cubes that can be made. Now, in my previous clip on surface area, I've showed how to use simultaneous equations to find these 3 edge lengths. But here I'm just going to do it by inspection. Okay, you need to think of 3 numbers, okay, which multiply together when 2 of the numbers multiply together to give 27, 2 of them multiply to give 15, and the other combination is to give 45. And I can see that factors of 27, 15 and 45, common factors, are actually 9, 3 and 5. So if the length is 9, width is 3 and height is 5, then I can find the volume by multiplying them together, and that gives 135 centimeters cubed. So the next step now is to find the volume of one of these small cubes. Since the edge length is 2.5, I can just do 2.5 cubed, which is 15.625. Since I need to see how many of these small cubes fit into this large cuboid, by dividing them through and then rounding down to the nearest whole number, I can get my answer, which is 8. And that's a reasonable answer, and that is 5 marks for that entire question. If you didn't follow through how I've got these edge lengths, be sure to look at my video clip on surface areas, which is also on this channel. Question 12. I'm given a diagram here and it shows a cuboid A, B, C, D, E, F, G, H. I'm told that AB equals 7 centimeters, which I can label on in a moment. I'm told that AF is 5 centimeters, but I'm also told this diagonal here from this vertex F to the opposite vertex C is 15 centimeters. So clearly this question involves 3D lengths. So this question actually involves 3D Pythagoras. I need to use that to find BC. When I found BC, which is this length here, I can then find the volume of the question, which is what I need. The entire question here is worth 4 marks. So let's follow it through now. So here's the steps I'm going to take. First thing I'm going to do is going to use 3D Pythagoras. If you're not sure on how to do that, be sure to look at my video clip on this channel or look at the PDF on MathsUpgrade.co.uk. Essentially, 3D Pythagoras, I can say 5 squared, which is this edge length, add 7 squared, this edge length, add BC squared, which is the depth there, gives the length of that diagonal squared. So to find BC squared, I can just do the length of that diagonal squared, subtract those other two edge lengths squared. And that gives me an answer of 12.29. Remember, you need to square root this to get that answer there. The next thing I can do, now that I've found that the edge lengths are 5, 7 and 12.29, I can find the volume. And that's straightforward, using length times width times height. Remember to round it, and the entire question there is 4 marks. Question 13 and 14 are really quite tough now. This first question here, question 13, the main topic here is actually bounds. If you're not sure on how to do bounds, then be sure to look at my video clip on my channel and look at the PDF on MathsUpgrade.co.uk. With this question, I'm told that Helen's got a fish tank in the shape of a cuboid. All the dimensions are correct to the nearest centimetre. This is really important. I'm going to underline this in a moment. She's going to use a bucket to fill that fish tank completely with water. There's 14 litres that she's got in a full bucket. And again, that's correct to the nearest litre. Will 25 buckets definitely fill the fish tank? Justify your answer. This entire question here is worth 4 marks. Here's the steps I'm going to take. I've noted the topic here at the top for your information as well. I've underlined the fact that this is to the nearest centimetre. I've written the formula for the volume here. And I reminded myself here that 1 litre is 1,000 centimetres cubed. This is important since I'm told the number of litres in the bucket, but the dimensions on this diagram are in centimetres. So the steps I'm going to take, I'm going to find the upper bounds of the dimensions of the cuboid. That means I'm going to find the largest possible volume of this cuboid. Okay, then I'm going to find the smallest possible volume of the bucket. I'm going to convert that into centimetres cubed, and then I'm going to divide those two volumes, and that should tell me enough information then to answer this question. So the upper bounds of the dimensions of the cuboid. Since the dimensions are correct to the nearest centimetre, then the greatest possible length is not 120, it's actually 120.5. So it's actually half a centimetre greater than what's quoted. Similarly for the width and height, the upper bounds are given there. The maximum volume of that cuboid then is going to be the length times width times height, which you can see their value there simply using a calculator. So that's the biggest possible volume of that cuboid. Now, since I need to see if I can definitely fill that fish tank, I need to see the smallest possible volume of the bucket. The smallest possible volume of the bucket is given by 13.5. So 13.5 litres is the smallest it could possibly be. Assuming it's the smallest, I times by 1,000 to give 13,500 centimetres cubed. There I've just converted from litres into centimetres cubed. And the last thing I'm going to do is I'm going to divide this largest possible volume of that fish tank divided by the smallest possible volume of that bucket. And that'll tell me the most number of buckets I could possibly need to fill that fish tank. And the answer there is 25.48575. I need to quote this exact decimal. I'm not going to round anything here. I need to quote the exact thing. So the question was, will 25 buckets definitely fill that fish tank? Justify your answer. And the answer is no. You cannot say they'll definitely fill the fish tank since all these values have been rounded here. If we assume the worst case scenario, she'll actually need almost half a bucket more to fill that. And that's what I've written there. The whole question there is worth 4 marks. Again, if you're not sure on bounds, be sure to look at my clip on my channel on that topic. Question 14. This is the last question in this booklet and arguably the most difficult. This question involves quadratics and also Pythagoras in 3D. So if you're not sure on either of those topics, be sure to look at the video clips on this channel or look at the PDF files on MathsUpgrade.co.uk. So I'm told a solid cuboid has got a volume of 40 centimetres cubed. The cuboid has got a total surface area of 100 centimetres squared. One edge of the cuboid has got length of 2. I need to find the length of a diagonal of the cuboid. Give my answer correct to 3 significant figures. So there's a lot of information there, and nothing on the diagram. So let's label some of that up on the diagram. So I'm told that one edge of the cuboid has got length of 2, so I've labelled that as 2 there. I don't know anything about the height, so I'm just going to use the letter H, and I don't know anything about the length, so I'm just using the letter L. The steps I'm going to take now is I'm going to form an equation for the surface area. I can only form an equation since I'm only given really one value here. I'm also going to form an equation for the volume. I'm going to use both equations to find the length and height of this cuboid. Then, once I've got that, it's just a matter of using Pythagoras in 3D to find the length of that diagonal, and remember to round your answer to 3 significant figures. The whole question there is worth 6 marks, and it is a tough question. So the first things first, I'm going to find the surface area of the cuboid. The surface area of this cuboid is given by the area of this front face, which is just a rectangle, base times height, 2h, the area of this side face, which is HL, and the area of the front face, which is 2L. Since these are 3 visible faces, I know there's 3 hidden faces which are equal in that area, so I'm just going to find the sum of this and then double that. I'm putting that as equal to 100, since I'm told that the total surface area is 100 centimeters squared in the question. Expanding this bracket out, I get 4h plus 4l plus 2hl equals 100. The next thing I'm going to do, I'm just going to leave this equation as it is for now. I'm going to find an equation for the volume. Remember, I'm told that the volume is 40 centimeters cubed in the information of the question. I also know that the volume is length times width times height. The length I'm given as the letter L, the height is h, and the width is 2. So 2hl equals 40. If I just simplify this slightly by dividing by 2 on both sides, I know that HL is 20. And rearranging that to make L the subject of the equation, L is 20 divided by H. Now what I can do here, because I can now substitute this equation into the equation I found earlier. Substituting it in, I get this here at the bottom. So 100, which is here, is equal to 4h plus 4l, which is 4 times 20 over h, plus 2h times l. So 2h times 20 over h. I'm just going to neaten this up a bit by combining the 4 times 20 and the 2h times 20, and these two h's cancel each other out. Now what I'm going to do is I'm going to subtract 100 from both sides, which gives me 4h plus 80 over h minus 60. What I'm going to do now, because I don't like having an h as a denominator here, I'm just going to multiply both sides of this entire equation by h, and I'm going to divide by a factor of 4. So what that gives me is 0 equals h squared minus 15h plus 20. Just note here, I've swapped these two terms round, which is why these numbers may look slightly wrong, but they're actually correct. I'm going to now write this as a quadratic equation, and then I'm going to substitute it into the quadratic formula. So I know that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And when I substitute the values for a, b and c into here, this is what I get. So using a calculator, I get the height as being 13.52 and the height as being 1.479. So there's 2 solutions for the height. And there's 2 solutions for the height, since I could have labelled the height as being this long side or this vertical edge here. Now if I follow through and substitute the height in for length into this equation here, I actually get the opposite values for the length. So this confirms that my solutions are indeed correct. Now what I need to do now is, since I know all the edge lengths now, I can now use Pythagoras in 3D to find the length of that diagonal. And that is given by the length squared plus the height squared plus the width squared, all square rooted to 3 significant figures. That's 13.7 centimeters. The entire question there is worth 6 marks. It was a tough question. In conclusion, if you need support with these sorts of questions, be sure to look at my video clips on solving quadratics and on 3D Pythagoras.